Right, now, is this all working? Ooh. Right, now, is this all working? Ooh. Yes, things are working. Cool. Is this... Yes, things are working. Let's drop down that volume there. Cool. Cool. I am streaming. I am recording. Ooh. Ooh, it's all very exciting. So yeah, I'm ooh, let's just get that microphone down a bit. I'm all very new to all this. I usually stream with people who produce for me. So when I stream for work, I have people who manage StreamYard and produce things, and it's all fantastic. And now I'm doing this from home. I don't have any of that. It's just me and OBS. So yeah, let's see how we get on. I streamed a couple of times a few weeks ago, and OBS was playing nice. It was on my side, but it's been a while. So let's see whether all this works. Cool, cool. I'm just going to do a little bit more playing with OBS and just add a few more things to my setup, just because I can. So let me see. Let me see if I can find some cool stuff. I want to add a picture to it all. Let me find some pictures. Oh, I need to resume my OneDrive. I've got stuff on OneDrive. Where's the picture I want? Let's trying to find a picture on here. Where are we? Where are we? This is the picture I want. Okay. Ooh, and that's going to get very, very large in a minute. So I need to make it teeny, teeny, tiny. Let's get you a lot smaller. A lot smaller. There we go. Nice. Nice. That looks slightly better. Yes, my OBS setup is terrible, and I don't care. Yeah, I will get better at this kind of stuff at some point, but you know, not today. Not today. But that looks slightly nice with a little picture in the bottom there. Cool. Cool. So I thought today would be fun to learn something. Yeah, I'm trying to start getting going with streams on a semi-regular basis just to learn stuff. And drink coffee. Coffee. Gotta have the coffee. So I thought it'd be fun just to try and learn a bit of stuff. I want to try and stream, as I say, just to pick up something new, play with something, see where we end up. May end up with something that works, may end up with something that doesn't work. And what I want to play with today, what I got really excited about, was a new announcement from Edge Impulse. You know what? Let's see if I can find the thing from Edge Impulse. So let me know if you've heard of Edge Impulse. They're a fantastic company. It'd be great if you know if you've done anything with them. But yeah, Edge Impulse have this thing called FOMO, which I thought I would, try and cover because, don't want the fear of missing out on this, do we? But FOMO is their faster objects, more objects, object detection algorithm. So the idea of this is it's object detection, which is a type of AI where you train a model to recognize things, and it can then detect those things in an image. So you can say, I don't know, you teach it this is what a raccoon looks like, and then if you have an image with a raccoon in it, it goes, yep, the raccoon's there. I can see that raccoon. And it's kind of quite a cool bit of AI technology. Now, I've played with this in the past where it runs up in the cloud, where we have used Azure Custom Vision as kind of my tool of choice. Work for Microsoft, got to use a bit of Azure. And using that, you build these models that's kind of 50, 60 megabytes in size, but ideally run in the cloud. I mean, well, actually, I don't know how big they are in the cloud. If you export them, about 50, 60 meg in size. But they run in the cloud and they are big. Now, Edge Impulse focuses on TinyML, which is about taking these AI models and running them on teeny tiny little microcontrollers. I did some streams this week and last week running an AI model on a microcontroller that's kind of yay big, little teeny one called a Zhao, and that was designed to recognize the difference between rowing and running. So these models are designed to run on very, very small pieces of hardware. And Edge Impulse claim they can get 60 frames a second object detection on a Raspberry Pi 4. So one of these little puppies, this is a Linux computer. It costs, if you could get one brand new, it costs $35, but these are somewhat hard to get due to supply constraints at the moment. The various supply chain issues we have. Not so easy to get, but the idea is on a $35 computer, you can get 60 frames per second of object detection, which is pretty impressive. I was doing some stuff with the Jetson Nano that a mate of mine, Paul DiCarlo, came up with. And Jetson Nano, it's an NVIDIA device, it's got GPU on board, it's $100 worth of computer, and that can do real-time object detection using a model called YOLO at about 6 or 7 frames a second. And we are trying to do 60 frames a second on a Raspberry Pi. So I thought that'd be the fun thing to do. Let's play today and just see whether I can get that working. I've got a Raspberry Pi. I've got a Raspberry Pi camera module if we need that. We're going to need some kind of camera, I guess. So it's just, let's see what we get. I'm going to plan to hang out for a couple of hours and just see whether or not I could actually get anything working with FOMO. So what I will do is let's do all the social media thing. Let's tell the world that we're streaming live right now. Because, that's what all the cool kids do. So let's do this. We are live. Come join me. Cool. Do the social thing. Okay, so we're going to look at this FOMO. So here's an example of FOMO. This is using an Arduino Nicla, which is a new board from Arduino. Folks who make all the really cool microcontrollers that are designed for newbies, beginners, kids to learn on. It just happens to be a fantastic set of boards for doing all manner of things. And this video here, 30 frames per second on a Nicla Vision. So look, see, they're kind of getting that. This is beer bottles and Coke cans. And so it's not doing a bounding box. If you've done object detection before, normally you get a bounding box. You get a rectangle around the thing you're detecting. This is just doing circles. But that was pretty cool. That was pretty fast. And the board they're showing, Arduino Nicla Vision, is a Cortex M7 MCU. So let's actually check out this board. It is, it's small and low power. Let's see what the specs are for it. So, okay, it's reasonably powered actually. So it's a Cortex M7. So it's got dual ARM Cortex, so 2 processors in there. It goes up to 480 megahertz. That is fast for a microcontroller. That is fast. This is a beefy bit of kit. It's got a 2 megapixel camera on board. There's the camera. So it's actually, you get the whole board with the camera built in. So it's kind of great for this kind of thing. You can run stuff on the microcontroller and you've got the camera built in. Got a microphone as well. It's pretty cool. Let's see what else we've got in here. Oh, LED, OBS, IoT. Gotta have me an LED. Some pins. Yeah. Oh, Bluetooth and Wi-Fi. And crypto chip. Always useful for embedding all your keys for your IoT connections. Okay. Yeah. 480 megahertz processor with a 240 megahertz core. 2 mega flash, 1 mega RAM. Nice. The QSPI flash. So 16 megabytes of additional memory on there. This is a pretty capable board, actually. It's got a lot of the things on there. Like the fact it's got Wi-Fi. So you know what? If I click the buy now button, America's sold out. Okay, so it's a $100 board. So this is not a cheap board. It's fairly powerful. I'm saying it's fairly powerful, but it's not a cheap board. which I guess kind of makes sense for what you're getting out of it. But oh, that's quite nice. That's quite nice. Notify me when available. Yeah, I will do that. I will do that at some point. Plug your battery. Okay. I want one. I want one. I just can't get one at the moment because they are sold out. But that's what the demo on here. But they also said on the Raspberry Pi, which I do have some, it runs at 60 frames a second, which is pretty impressive. So, ooh, bit of face detection going on there. Is there a face? Yay! There's the face. Nice. There's probably kind of a lot of really useful use cases of this. Now, wildlife cam is probably a classic one. You know, a lot of people have these cameras they set up for various bits of wildlife that they've got around their home. Yeah, I had a bear once. Where I live, Pacific Northwest, we get bears. And I actually had a bear once. Around the corner of my house, just around over there. Got my bins down the side of my house, went to put something in the bins, looked along my fence, and there was a bear sitting on my fence. Big, proper, big black bear. You know, not like a small teddy bear. We're talking a big, scary bear on the fence. I did manage to get a photo because, you know, I'm that generation where if it's no photo of it, didn't happen. Managed to catch a photo of it. But yeah, it then climbed into my apple tree, broke my apple tree. Literally a branch that was 3/4 of the tree broke off. And then it knocked over my fence, heading out the back of the house. And so, you know, maybe I want to set up a camera to track bears. Get raccoons. Got a really nice cherry tree just starting to come into flower outside the back of my house. We get a raccoon in there. Old house we lived at, we used to get whole family raccoons coming in. This house, we get a raccoon. So, you know, one of these, slightly less cuddly, but real thing. So maybe I want to track raccoons. So something like that, I could run a low-powered microcontroller to recognize animals. Things like that would be pretty cool. So that's, I guess, the kind of use case I could use something like this for. Put it in my fridge. Find out when I've run out of milk. Oh, pretty cool. So yes, this is kind of the traditional object detection where you get a bounding box. So it's face, 0.65%. So you would get a bounding box to say, this is what I found. FOMO seems to work with just a little dot. It's here, somewhere here. So it's roughly where it is. You don't get the same bounding box, but you kind of get a rough location. That's cool. Okay, it's trained on Centroid. Okay, so the main design decisions are based on the idea that a lot of object detection problems don't actually need the size of the objects, but just their location in the frame. Okay, so this is the kind of thing is it there? How many? The kind of counting thing. Stock counting in a supermarket. How many boxes of cornflakes do I have? Don't really care where they are. I just want to count them. So this is kind of using for that. Okay, and then lots of cool stuff about how it does all the things with grids. Designed to be small and fast. Smallest version of FOMO with a 96 by 96 grayscale input. Runs in less than 100 kilobytes of RAM and 10 frames per second on a Cortex M4F at 80 megahertz. Wow, that's pretty impressive. An M4F at 80 megahertz is not a powerful machine. Getting 10 frames a second. That is pretty cool. Okay, cool. So let's actually head to the documentation. Let's see what we can do with this documentation. And this is where it says it. FOMO lets you do 60 frames per second object detection on Raspberry Pi 4. That is what I'm going to try and do today. Got the Raspberry Pi 4. I'm going to try and do this. So if anyone who's watching, if you've done any object detection before, if you've done anything with microcontrollers or small computers, let me know. And yeah, we'll see what we can do with this one. Right. So let's work through these docs. Let's make this a bit. So how does this magic work? Well, so first, a small primer. Let's say you want to detect whether you see a face in front of your sensor. You can approach this in two ways. You can train a simple binary classifier that says either face or no face, or train a complex object detection model, which tells you I see a face at this XY point and of this size. Object detection is thus great when you need to know the exact location of something, or if you want to count multiple things. So a classifier here would say, yes, this is Jan, and object detector says, Jan's face is here. So this guy, the CTO of Edge Impulse, I had the pleasure of hanging out with him once at an event at a university in the UK, where we were there to kind of support the students. Crazy chap, absolutely brilliant. Love his demos, they're all just way over the top, it's great. So design goal for FOMO was to get the best of both worlds. computational power required for image classification with the additional information, location, and object count. So it's kind of trying to do, you're kind of doing that classification thing, because classification needs less power than object detection, because it's just a yes or no thing, but trying to do that with object count. Okay, so the first thing to realize is that while the output of the image classifies a face, no face, with no locality, so no location, the underlying neural network architecture consists of a number of convolutional layers. The way to think about these layers is that every layer creates a diffuse, low-resolution image of the previous layer. So you have a 16 by 16 image. The width height of the layers is 16 by 16, 4 by 4, 1 by 1. Okay, so each pixel in the second layer maps to a 4 by 4 block, and the locality is somewhat preserved. Okay, the pixel in layer 2, 0, 0 will roughly map back to the top left corner of the input image. The deeper you go in a normal image classification network, the less this locality or receptive field is preserved until you finally have just one outcome. Okay, not entirely sure what that means. FOMO uses the same architecture but cuts to the last layers of a standard image classification model and replaces the layer with a per region class probability map. So 4 by 4 map, for example, above. Then has a custom loss function which forces the network to fully preserve the locality in the final layer. Essentially gives you a heat map of where the objects are. Okay. So essentially it's running a classifier across all the different areas and building up a heat map of where things match the classifier. And so depending on where you do the cutoff, when you're shrinking down these layers, you get different resolutions of the heat map. So it's kind of look at different parts of it to see where they're classifying and building up like a heat map of where they are. Okay. Sets to 1-to-1 gives you pixel level segmentation and basically count a lot of small objects. So here is, what are we counting here? Bees! Here is bees. So they're actually counting. That's pretty impressive. It's an early version of it. It's counting all these bees. That's a lot of bees. That's a lot of counting. That is really impressive. So the difference between FOMO and other object detection algorithms is it does not output bounding boxes. It's easy to go from heat map to bounding boxes. Just draw a box on the highlighted area. Okay. However, when working with early customers, we realised that bounding boxes are merely an implementation detail of other object detection networks and not a typical requirement. Very often, the size of the objects is not important as cameras are in fixed locations and objects thus fixed size, but rather you just want the location and count of the objects, which I guess makes sense. So if you're in a supermarket and you've got cameras to see how your stock levels are, do we have a full shelf of cornflake boxes? You know how big the cornflake box is. So in your camera in a fixed location, you know the cornflake box might be, 20 pixels wide by 30 pixels high. So as long as you know there's a cornflake box there, and there, there's 3 cornflake boxes, that's enough. You don't really care where they are. So guess, yeah, that kind of makes sense. I think that kind of makes sense. So thus we train on the centroids of objects. Centroids sounds like a really bad 60s science fiction movie. The centroids are coming! This makes it much easier to count objects that are close. Every activation of the heat map is an object. The convolutional nature of the neural network ensures we look around the centroid for the object anyway. Beer, beer, beer. There we go. Beer, beer, beer. So this is kind of the original version. We got the bounding boxes, and this is the... this is the training data, actually. I guess this is the output. Beer, beer, beer. So we train it with where it is. We just do circles. Downside of the heat map is that FOMO is that each cell acts as its own classifier. If your class is a lamp, plant, and background, each cell will be either lamp, plant, or background. It's not possible to check objects with overlapping centroids. Okay, so if they do overlap, you won't actually get the fact they've overlapped. But you can use a higher resolution heat map to kind of solve this problem. Okay, so there are kind of limitations and ups and downsides to it. If you're doing supermarket example, you're not going to have your cornflakes heavily overlap with your Rice Krispies. So yeah, it's can't do physical objects in space. Cool. Cool benefit for FOMO, it's fully convolutional. If you set an image heat map factor of 8, you can throw in a 96 by 96 image, 320 by 320, or even 1024 by 1024. It's incredibly flexible and useful even if you have very large images that need to be analysed. So fault detection where the faults may be very, very small. So if you look like a big circuit board and you've got like a small fault in something, then that fault could be tiny. You want to be able to catch that. So it kind of works with large images. So if you've got like a conveyor belt and you have hard circuit boards going across it, and you have a camera to do that. This can work with that. It's compatible with any MobileNet V2 model. Depending on where the model needs to run, you can pick a model with higher or low alpha, and transfer learning also works. So you can use it. So if it's a MobileNet V2, what is MobileNet V2? I guess this one is. That doesn't tell me much. It's all about PyTorch. MobileNet V2 explained. So it's a convolutional neural network architecture that seeks to perform well on mobile devices. Inverted residual structure with the residual connectors between the bottleneck layers. Okay, that's completely meaningless to me. I have no idea what that means. But essentially, it's an existing neural network standard. So if you've got a MobileNet V2, too many Windows 7. If you've got a MobileNet V2 model already, you can just use that in FOMO. That's pretty cool. So FOMO can scale from microcontrollers all the way to full gateways or GPUs. So again, if you want to scale this up to like an NVIDIA Jetson Nano, I've got one here actually. Where is it? All bundled up in its cables. But yeah, I mean, here's a Jetson Nano, for example. Tucked away inside there, that's a Jetson Nano. That's an NVIDIA board. Very, very powerful. Well, I say very powerful. $100 worth of power. But it's based around a GPU. Essentially, it's a big NVIDIA GPU for running models. So it sounds like if you use one of these, you'll get much better performance. So I could take my model, I could run it on a teeny tiny little microcontroller, or I can just kind of scale it up to larger devices. So it'd be interesting to maybe, once I've got it working, maybe see how fast it is on a Jetson Nano. So 60 times a second on the Raspberry Pi 4 at 160 by 160 grayscale input. That's 20 times faster than MobileNet SSD, which is 3 frames a second. So this is pretty quick. Pretty quick. Second video is 30 times a second on Arduino NickleVision with a Cortex M7 running at 480 megahertz. This is slightly smaller input, so it's half the speed, slightly smaller input, which is fair enough because it's a Cortex M7 running at 480 megahertz and a Raspberry Pi 4 is a quad-core 1 point whatever gigahertz processor. It's running a HiMax WEI Plus, 14 frames a second, under 150 kilobytes of RAM, 96 by 96 grayscale input. What is a HiMax WE1 Plus? Okay, so it's another board with a camera built in. $65 from SparkFun. Okay. That can do the thing. Cool. And the smallest version of FOMO, 96 by 96 grayscale input, runs in less than 100 kilobytes of RAM at approximately 10 frames a second, Cortex M4F at 80 megahertz. Now, what I'm interested in actually is there's an ESP32 CAM board. So this is a really cool board. I wonder how it would work on one of these. So it's an ESP32 system on a chip with built-in camera. It's a pretty nice little board. I mean, if you look on Amazon, I mean, a 2-pack of ESP32 CAM. So 2-pack of the board with a camera, Wi-Fi capability is $18. So an ESP32 CAM took a $15 microcontroller. That'd be another interesting thing to do. Try it on the Raspberry Pi first, and then maybe next time I could try it on a Jetson Nano and an ESP32 CAM and kind of see kind of what the two extremes are of the levels of power we can get out of this thing. This is cool. Cool. These two, the lower power ones, is compiled using the Eon compiler. And the Eon compiler is this cool thing that compiles your models to make them more powerful. 55% less RAM, 35% less ROM. To make your models a lot smaller. Which is pretty cool. So, yeah, here's an example here. Eon compiler, uncompiled 18K of RAM, compiled 12.3K RAM. So you kind of got that ability to kind of compile it down even smaller. Which is pretty cool. Okay, so how to get started? Create a new project at Edge Impulse. Make sure to select the label method of bounding boxes. Collect and prepare your data sets and object detection. Add object detection images to Impulse. Under object detection, choose model. FOMO models. Okay. Okay. You know what? Let's move tab to a new window here. Let's do some of this. Let's put that there. Let's close that. Let's just log into Edge Impulse. Okay, and let's create a new project. So let's do this. We'll call this FOMO RPI, Raspberry Pi. Let's create the project. Now, Edge Impulse, you've not used it before. It's fantastic online training and building of TinyML models. It's currently free for developers. They have enterprise licenses for enterprise people who have lots of money, but it's just free for developers like you and I to just build stuff. Create a new project. We want images. Classify multiple objects, object detection. Okay, so their basic one, the basic object detection is Raspberry Pi 4 Jets and Nanos. Let's choose that. Connect your development board. Raspberry Pi 4. So, yeah. Oh, the docs are out of date. You don't need to change your WPA supplicant cough. What you want to do is you want to use the Raspberry Pi imager and do all that automatically for you. Right, connect. Yeah, whatever. Right, let's install all the things. So I'm connected to my Raspberry Pi. Here's my Pi here. My Raspberry Pi 4. Connected to it via a terminal. Let's just run all the things. So this is installing some packages. And installing, what do we do? Installing Node, I guess. deb.nodesource.com. So installing Node, yeah. And then installing GCC and other stuff. So this is just installing. Let's look at what is this installing. Node source, installing GCC, G++, Make, Build Essential, Node.js, Socks, GStreamer tools. Okay, that's tools for kind of putting stuff off cameras. And then doing some and then installing the Edge Impulse Linux thing. And then if you have a Raspberry Pi camera module, you need to activate it first. So you know what, while this is running, I'm going to grab my Raspberry Pi camera module. Back in a second. Raspberry Pi camera module. One of these. So I need to install that in just a tick. I'll wait for the stuff to install and I'll be good. I will power down my Pi before I install my thing. So I should be good. Okay, still installing. So the Edge Impulse CLI is command line tool, runs on your board, connects up to Edge Impulse, and then allows you to stream data from your device up into the cloud. So up into Edge Impulse. Kind of saves you having to manually upload data. You can literally capture it directly from your board. Okay. So that's still going. Installing npm things. No idea how long this takes. Could be here all week with this, I don't know. But no, it's installing. It's doing its thing. But I've used the npm CLI, Edge Impulse CLI before for doing accelerometer capture. So I had a little seed Zhao board, had accelerometer on there, picking up data, and I'm able to doing rowing and running to kind of build a fitness tracker. And you literally just connect it and you do your thing. It just sucks the data off and sends the data up to the cloud. It's fantastic. I do like Edge Impulses. Some very cool stuff. I know nothing about building these models. So I know nothing about how much you're going to get these models working. But you know what? It's a bit of fun, isn't it? So yeah, anyone watching, if you've done anything with these kind of models, let me know. Be interested to see who else has played with Edge Impulse or got anywhere with it. It's all very quiet in the chat. Is there anyone there? Hello. Cool. Okay, so we've installed, done all the thing. And then we do need to enable the camera. So sudo Raspberry config and then interface options. Ooh. This is interesting. So Raspberry Pi changed all the camera McGubbins. They changed the camera stuff. They've got some new stuff in Bullseye, and this is saying, should we use Bullseye? Bullseye release. Okay. So, do we need the legacy camera? Or just not? Because under interface options, I only have legacy camera. You know what, let's just power down my Pi, plug in the camera, just see what happens. So you know what I'm going to do? I'm going to change Pis. I'm going to change Pis. The reason I'm going to change Pis is I've got one here in a case. It's got a little stand at the front there that I can mount the camera on. Of course, Raspberry Pi being Raspberry Pi, I just literally take out the SD card, chuck it in there, and then I can then just connect to this. All the software installed is installed. So let's try it. Let's just plug this in with this camera, and we'll just see what happens. Now, obviously, terminal's going to complain because I've just powered it down. Switch terminal, and then what I need to do is, where I've just changed the Pi, it's not going to be very happy with me. So I need to I can't remember what the path is to do the thing now. But you know what? Let's just Pi add Raspberry Pi.local. My password. Okay, I thought it was going to complain because the SSH fingerprint would have changed, but it didn't. So we are good. We are in, and we've got the device. So let's actually launch the thingy. Let's run. Make this window a bit. Let's do the thingy. Okay. Now I need to do some secret stuff here now. You know, password's not like this. Jim.bennett at Microsoft.com. Password, let's copy that from over there. Ooh, right. So we're in, I choose my FOMO RPI project. Now, I don't want a microphone. So you know what, let's do that again. Because I just want the camera, that's what I want. So some weird thing about the camera. So maybe it does need the legacy. Need the legacy camera module. Let's find out. Interface options. Legacy camera. Yes. Let's enable it. Okay. Guess we're gonna have to reboot. So let's see what that does. See if the legacy camera thing actually does the thing that it needs to do. Just connect again. Okay, wait for a bit longer for it to reboot. And then hopefully, come on, reboot. There we go. And we're in. Huh. Something not right about that camera. Says, okay, let's go. Let's have a look. Let's do something in documentation. So it's basically this is the same thing I'm working through, isn't it? It's the same thing. Yeah, same doc. Okay. Let's go and check their forums, see if anyone put this in the forums. Search here. Raspberry Pi camera. Camera question. Okay, I'm not saying anything useful. Because this is like last year. So this is before they did all the legacy camera changes. Okay, it's a weird searchy thing. So Raspberry Pi camera. More. Let's see if we get some. Aha, that's like exact same as my error. Okay, so let's just try the basically try lib camera. Hello. Okay, so lib camera is the legacy camera stack. Okay, so let's go back to Raspberry config and interface options, legacy camera, disable legacy camera support. Because that's the only camera option I've got is the legacy camera. Okay, let's reboot this thing and let's see what we've got support in Bullseye. Because they mentioned about the new camera. Okay, because that's how to enable the legacy camera stack. But how do you enable the non-legacy camera stack? Okay, well, let's just wait for it to reboot. And let's try that. Okay, I mean, it's obviously, I guess it's there. The fact it did something. Let's try that. Nope. Okay, that's not very useful documentation. Right. Let's look at the lib camera stuff then. Let's just do that. Let's look at the lib camera stuff. Check everything working by lib camera. Hello. Shift your camera preview in about 5 seconds. Doesn't work because I'm doing the I'm using Raspberry Pi Lite. Right. Where's the? I don't want a preview window. Lib camera JPEG. So -O. There we go. It'd be nice if the doc said, instead of just saying error output name required, it'd be nice if it actually tells you what, how you specify the output name. What's the actual documentation for it? Okay, so if I do this, we've got test.jpg. Okay, so we have an image there. And it's 13.5K in size. You know what? Let's just go here. Let's go to VS Code. Because, this is how all the cool kids do stuff. Remote, SSH, connect current window to host, pi at Raspberry Pi local. Put my password. Because I can actually browse in here and actually look at that JPEG. See if I actually got anything in there. Second, this is doing its thing. Oh, there we go. Nice. So I'm just going to open the home Pi folder because I can. Put in my password again. Yes, I trust all the things. So it's upside down. It's my elbow because my camera's down there. But yeah, this is so the camera is working. Okay, so if I just go back to the Edge Impulse thingy. See what happens. Huh. So it doesn't like it. Failed to initialize Linux tool. Error code was not zero probing devices. So I'm still getting that same issue. So go back to this. So doing what Carlisle did here, that works. Okay. Problem solved. We're going to Buster. Okay. So they've said in V130, they've fixed that in V130 of the tool. So you know what? Let's try 135. So it's... Okay, so it's supposedly fixed. But it's not. Okay. So the response is don't use OS Lite. Okay, so we can't use the Raspberry Pi OS Lite. We've got to use the full version of Raspberry Pi OS. That's slightly annoying. So you know what? Do I have a full version of Raspberry Pi OS on an SD card? No, I don't. First thing I was going to check is let's check my 400. But there's no SD card in there. Okay, so I guess what we're going to have to do then is a very boring re-image my SD card. So let's just put you in there, take the SD card out, put it in, and Raspberry Pi imager. Boo! Because that's going to take some time. So choose OS, Raspberry Pi OS, choose storage, that one there, right. Okay. So now we've got to write the whole Raspberry Pi OS, and that's not going to be exactly fast. So it seems it is a bug that Edge Impulse doesn't like working with Raspberry Pi OS Lite. Oh well. What can you do? What can you do? Let's see what. Yeah. Okay. Okay. So maybe what we do, we actually get some existing images. Maybe that would be the thing. Let's go to the uploader. Okay, let's actually look at there. Let's look at the docs and how we collect data from data. While we're waiting, let's actually look at the docs. Elephant. Cool. Yep, FOMO, that's what we're trying to get to. Yeah. Okay. Raspberry Pi 4 is being sorted. NVIDIA Jetson Nano, don't have that plugged in. Intel-based Mac, come on. You know, they've been making Apple Silicon ones for over a year now. Linux thing, mobile phone. Okay. Right, but okay, we might be using a mobile phone client to upload images. Okay. Yeah, Intel-based Mac. I mean, that's seen a lot of that. It's like, oh, we only support Intel-based Macs on a lot of places. Microsoft, we also have the same thing for some of our stuff. We only support Intel-based Macs. Like, yeah, I think there's only one you can buy now. Most of them are Apple Silicon. So, yeah, they've obviously got stuff that runs on ARM because it runs on Pi and NVIDIA Jetson. But hey, okay, so we can probably use their mobile uploader. So based off that, then, what I should probably do is take some photos. That would be a useful thing to do. And if I actually take some photos of stuff that I want to have photos of, that I want to use my object detector for, I can upload those from my phone. So what should we detect? Should we detect bit? Do that? Okay. So let me take a load of photos. And see if I can just use those photos. So let's get my camera out and just... So I wonder how many photos. 30 images they're saying there. Okay, so just doing 30 images across my desk. And then, you know what? Because it's always better to have two bits, you know. Let's get two. Let's do some photographs with two of them in there. them all in the same location. You know, I guess it doesn't matter because I'll be testing at the same location. Okay, let me see how many pictures I've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45 pictures. Okay, that's 45 pictures. So let's create a new album for those. Call it Bit, because that's the name of this raccoon. Done. Okay, so upload some images of raccoons, all the things. Let's actually connect my phone. So let's go back here to my dashboard, and then what does it say? Mobile phone. Follow these instructions. Mobile phone. Okay, go here. Go to my devices page. Devices. Connect a new device. Use your mobile phone. Okay. So let's do that now. Let's get my mobile phone out. Come on. Camera. Cool. Okay. Right, I don't want to capture the camera. What I want to do is I want to... Okay, I guess we'll have to recapture everything. So that's me capturing all those things. Oh well, let's actually try it. There's a bit there. So I'm capturing all things. It probably doesn't look very interesting, but I'm actually capturing all this data. So I am doing stuff. I'm not just lounging back in my chair. So let's go some images. And then... Right, so if I actually look at my data acquisition. Okay, I've got 42 images. Cool. So if I go here, edit labels. Okay, cool. So now I kind of got back to the point where I can do something. So while we're waiting for that SD card to go, because that's going to take a long time, I can actually do something here. So let's draw a box around raccoon. Call this Bit. Set label. Save labels. Okay, I've got a feeling this is going to be... Data collected 29 items. It's probably more than 29 items, I guess. The labeling queue 41. Okay. This is going to be one of these very boring things where this is the downside to object detection. It is very, very dull, this part. We could be here a while, folks. So, you know. This is going to be... Yeah, object detection is kind of painful like this sometimes, just gathering all this data. And, you know, I'm just doing the smallest number of objects I can get, a number of images I can get away with. You know, there's probably people who spend all day, every day, just drawing bounding boxes, adding labels. You know, it's kind of what you need to do if you want to get all this stuff working. But it's just, it's painful. It is painful. So the Microsoft custom vision service. One thing that does, it will try and detect objects in your image, and so it can kind of predict where the bounding box should be, which is pretty cool, because then you just click on the one the bounding boxes come up with and just click on a label. So it can be a lot quicker, but still, it's not interesting. Okay, wow, this is. So yeah, apologies to everyone watching. This is not exactly the interesting thing to watch, but this is just one of the things you have to do. Let's filter my data based off. No, I don't want to filter it. I don't want to filter it. Just wondering if I can filter just to kind of see them, but no, let's go to page 2. Edit labels. Okay, set labels. If anyone's ever had to do this, let me know, because it's painful. Yeah. Tell me your horror stories. Entertain me whilst I'm drawing these blimmin' boxes around. So I want to time this perfectly. Just as I'm ending, start telling a joke about a woman walking into a bar with a salami under one arm and a chihuahua under the other. And then never actually do the punchline because I get to the end. Any John Hughes fans watching may understand where that comes from. If you've not heard of it, it's from a movie called The Breakfast Club back in the 80s. Guy's kind of crawling through a vent, starts cracking this joke, and then falls through a hole before we get the punchline. No one knows what the punchline is. Oh, this is so dull. This is so dull. But it's just got to be done. Yeah, it's how we do our data, really. Now, of course, the problem is this is all captured with my mobile phone. When we actually get the Raspberry Pi camera working, it may be a completely different set of data. Just don't know. Just don't know what it's going to be like. Okay. Oh. So save labels, edit labels. Oh. Wonder if people like this kind of stuff. When there's like a Twitch channel for watching people just doing data entry like this, just watching people doing mundane things. Set label. Oh, almost there with this set. I need to make sure. Oh, and then I need to make sure I've got all the things. Because it's saying 30 images. I need 30 images to do it. Because what it recommends, object detection. Yeah, 30 images. And we've got 29. Let's do one more just to complete this set. Images, edit labels. There we go. Okay, so we've got 30 images. We've got some data. Well, let's go and check on this thing. Still going. Oh, it's painful. Right, label data. Oh, it's got AI assisted labeling. So they've actually got that. Cool. Rebalance your data set. Okay, so let's rebalance the data set. So this is the cool thing where Where is it? Where did you go back to? Dashboard. So rebalance data set. What it will do is that will take. It's not rebalance data set. It's perform train test split. And what that does, that actually splits my data. So if I actually look at my data acquisition, I now have. Yeah. I thought I did that. Okay, there's still more that haven't been labelled. I thought I labelled them all. Oh, now it's doing automatically. Yes, nice. Ooh, oh, hello. This is very nice. It is literally. Detecting this. And making it easy for me. Yeah. Didn't get that one anywhere near correct. But you know what? Oh, this is very nice. I like this. I like this. Don't know how I didn't spot this before. Okay, so now I have training data. There you go. So 13 test items, 30 training items. 70-30 train test split. Okay, that can do. So if we just start with an object detector, I guess, start with one of those. What do we need to do that? Let's have a look. Prepare your data sets. We've got the data set. Okay, so we've kind of got the data there, and it's still writing Raspberry Pi OS. So we've got the data there. Let's actually design our impulse. This is the bit where we build the model. So, you know what, let's just zoom out. I'm going to zoom out a little bit. So image data. How big do you want our images? Let's go slightly bigger. 320 by 320. Let's just do that. Because, you know, it kind of makes sense to the highest resolution one. And then add an object and images block to your impulse. So we need the processing block first. Okay, so we need to... Got the images labeled, balanced. So we need the image processing block. So that says it's an image. And then our learning block, object detection images, add that. Under object detection, choose a different model. Where do I do that? Make sure labeling methods, bounding boxes, object detection. Okay, is that what I did? How do I... Labeling method, bounding box object detection. Yep, that's right. So it's the right one. So if I go to my impulse, design, I didn't save it, okay. Whatever, add a processing block, image, add a learning block, object detection. Okay, out. And then it says choose a different model. Under object detection, select choose a different model. How? Do I have to do that? Oh, here, under object detection, here. One of these P blocks not had features generated. Okay, so I go here, create impulse. Yeah, image. Generate features. Okay. Yeah, yeah. So create the impulse. So probably want do I want grayscale? I don't know. Generate features. So this does some stuff. So let's actually go through the image and work out all the features, all the kind of different bits that make up the image, and do stuff with that. So let's just kind of just run that. So I very much don't know what I'm doing. I'm just kind of just clicking the things and hoping. And waiting for this to finish so I can run it to my Raspberry Pi. So yeah, feedback for Edge Impulse. Make it work on a Raspberry Pi Lite. That'd be lovely. So job is started. I don't know how long this job's going to take to run. No, I don't know. Oh, there we go. Creating Windows from 30 files. But I'm not Windows, I'm running on a Mac, not Windows. Nah. So it's doing its thing. Creating Windows from files. Scheduling jobs. Chug, chug, chug. So that's chugging away. That's chugging away. Lots of things just chugging away, doing their thing. Okay, so when that's done, it gives us Feature Explorer, which we've only got one thing we're detecting, so it won't be very interesting. We just see stuff clustered away. A thing. But it's doing its thing. Oh, finding nearest neighbours. Don't know what nearest neighbour is, but it's finding one. Construct embedding. Job completed. So we generated features. Okay. So it reckons this is one thing I do like about Edge Impulse. This tells me how long it will run. So based off a Raspberry Pi 4, it'll take 1 millisecond and use 4 kilobytes of RAM to do whatever processing it needs to do to generate the features from an image. So that's to get the image ready to run through the AI model. Okay, so now I've got object detection, and then choose a. Oh. So it says choose a different model. Select one of the FOMO models. It looks like it's already selected the FOMO model. Looks like it's already selected FOMO. Vignette 2, 3.5, that one there. Nice. Learning rates 001 star. Okay, so let's start training. So FOMO is currently compatible with all fully supported development boards that have a camera, and with Edge Impulse for Linux, any client. Of course, you can export your model as C++ library and integrate it as usual on any device or development board. The output format of models is compatible with normal object detection models, and our SDK runs on almost anything under the sun, from RTOSes to bare metal to special accelerators and GPUs. Cool. Okay, so what it's going to spit out, it will work, in theory, work anywhere. And then hopefully we'll just test it with Raspberry Pi when that's working. That's pretty cool. Oh. Let me click on that, see what that was. Running jobs using an API. There is an API for this. Ooh. That could be cool. Because then you could literally script up running a job. You just give it the images. And you script up, it runs the job. So runs some scripting. Go up and create a project for you. Upload all your images. Build it, train it, get everything back. Once it's got it back, you could then spit out some code, and then you could even use Platform IO, via the PIO command line tool, to program a board. So yeah, what if you could do it? You could literally script, you just have something. Or if as long as you've got the images, the bounding boxes. Ooh. That could be fun. I might have to play with that at some point, this API. Okay, so we're training. I think we're doing 60 epochs. 8, 9, 10. Okay, so it's just chugging away, doing its thing. Verify. I don't care about the verify. I just want it now. Cool. Raspberry image. Let's quit that. So in theory now then, I take out my full Raspberry Pi OS, plug that in. Gonna have to wait for it to do its thing. Takes a bit longer to boot up because it's the full version of the Raspberry Pi OS. So let's just relaunch my terminal because it would have just gone a bit haywire where I just unplugged it. So that's still running. It's going to take a while for it to connect because it's booting the full Raspberry Pi operating system. Don't have a monitor connected, so hopefully it'll work if I connect remotely. Okay, give it a bit longer to connect. But yes, we're still going. We're still on our epoch, 20-second epoch. So let's see how it does. Lots of waiting with this. Come on, you can catch up. You can be available to log in. So I'm kind of trying to call these streams Jim Learns Stuff, and right now it's Jim Tries to Learn Patience. Perhaps I should meditate, you know. Just sit here and just meditate for a few minutes. Maybe we should all just take a moment to meditate while we wait. Nah. Yeah, I'm wondering, actually. I'm wondering, because I've got the, you know, with the website, I wonder. I was just collecting. So I'm just looking at the mobile app. Look at the mobile app here. And you can use it for kind of collecting images, collecting audio, and collect motion. So it's just as data acquisition, but it doesn't seem to give me a thing for actually testing my model. That'd be quite a nice thing to have, really. Train a model for your phone, test it for your phone. There we go. So that's still attaching to jobs. I guess it's kind of just scheduling time to do things. You gonna let me in? It's gonna be one of them things where I've actually got to connect it to my monitor and set it all up for it to work, isn't it? Come on. Just gonna be very annoying. Very annoying indeed. Okay. Maybe I'll set up the Pi later and we'll do that. Do that another day. Okay. So here we go. So inference on a Raspberry Pi for 140 milliseconds. Which is not really 60 frames a second. But that's because we haven't tuned it with the Eon tuner, maybe. Yeah, so that's my model, trained. So in theory it's trained now. Okay. So I could tune my model. So it looks like I really need my Raspberry Pi working to make this all happen. It looks like I really need it to work. So it means I have to plug in my monitor, which is the same monitor I'm using to stream from. So things might get a bit strange. So I'm just appearing to do some cabling. Let's plug you to HDMI 2. Let's bring you around and plug you in to here. And then actually, you know what? No, let's not do that. Let's not do that. Let me. No, don't do that because then I won't work. Plug you in there. Plug you in there. Let's get some power going into there. And then I need a keyboard. Where's my keyboard? One of these little doodah ones. The little dongle. Plug in the dongle. The thingy. And then hopefully, I'm just rebooting this a few times. So hopefully, what I'm doing now, you won't see it because I'm just plugging in a different screen. Well, I'm plugging the same thing in to my monitor, but obviously, you know, in my monitor, you can't see that because you only see what's on the stream. What I'm trying to do is just get my Raspberry Pi to connect to my monitor so I can see what's going on and get it working. There we go. Okay. Right, so I've now got it connected. Working with Raspberry Pi desktop next. So I'm just doing the boring setup on my Pi. Time zone. Things like time zones, Los Angeles. Next. Right. So hopefully once I got this working, I can then just VNC into it and you can see what I'm doing. So you just have to listen to me talk for a little bit whilst I work through the setup on here. So you set Wi-Fi on this Pi first. One's got Wi-Fi. Because the Wi-Fi should have been set up already because I set that in the thingy. But I guess maybe where I changed the operating system in there that I was installed in the imager, maybe that broke things. Maybe. Okay, so once I get this on the Wi-Fi, then I'm going to connect to it. I won't bother updating software right now. Done. Preferences. Raspberry Pi configuration. Let's enable VNC. This is what we want. So interfaces. SSH and VNC. Let's enable those. Kind of important really, if you want to actually have anything, if you want to better connect to it. Okay, and then if I do the VNC, what I'm going to do, I'm just going to change the screen resolution. Make it smaller so it looks a bit better in VNC because I've got one of them stupidly wide monitors. And so if I just do it something a bit smaller. Right, I'm just going to reboot my Pi. Hopefully I'll sort up my screen layout to be a bit smaller and then I can VNC from my Mac and you can see what I'm doing. All good fun. But in theory now though, when this boots up I should be able to just SSH into it. I don't have a VNC client installed. Let's actually install a VNC client. Download VNC viewer. Cool, it's downloaded. That's the one I normally like to use. Okay, host key verification failed. Nice. This is what I expected to happen because it's got a different name. So you know what? Let's just go in there and just go save that. But in theory now, if I go in here, yes. Cool. So I'm now connected, and in theory, if I can get this VNC client set up, Yep, open that. Yep, I agree with these terms and conditions. I'm not even going to read. It is pi at Raspberry Pi.local. Oh, no, actually, it's not those. It's just Raspberry Pi.local. Silly me. Okay, so go here. Yep, it's fine. Username pi. Enter a password. Okay, let's just do some stuff for accessibility because, you know, Mac's got so many nice little security features to stop weird things happening, and then accessibility VNC viewer. Cool. So I'm now connected to my Pi. So let's see if the camera thing is working. So what was that camera tool we had? There was a camera tool we were using, weren't we? That did the thing to check whether everything worked or not. So here we go. It's lib camera. So lib camera hello. So if I go here, go to the terminal. Lib camera hello. And there we go. My camera's upside down. Because that's just one of the weird things about the camera modules. But that's cool. So the camera is working. Nice. Now how do we do the camera config to rotate the camera? What does the configuration do to rotate the camera? It's got to be a... Could be a way to rotate it because the cable comes out the bottom of the camera, which is all right if you've got some kind of holder where you can hold the cable at the bottom, but not so annoying. Raspberry Pi default rotation on camera. Is there a way to set that? Yeah, no, it looks like there isn't. Oh well. Oh well, I'm sure it'll be fine. We can work something out. So now I need to go back and install the Raspberry Pi thing for Linux because I didn't do all the things. So let's go in here. Let's install all the dependencies. So that's going to sit there and check away all the dependency things. Let's move this keyboard out of the way. Don't need that for now. So hopefully now, with these dependencies installed, because we're using the full version of Raspberry Pi OS, then it should hopefully, fingers crossed, allow me to do the thing that captures the data that connects into the camera. But we shall see. So while it's doing that, let's go back to our actual Edge Impulse thing. And so let's tune this for Raspberry Pi 4. Search process will take 6 hours to complete. Yeah, maybe not. Let's not do that because that's going to be slow. But let's actually look at the model. So if we go to live classification, okay, that's capturing data from a device, which now there. Model testing. Let's try actually run through our test data. Let's see what happens when we test it. Could be interesting. No idea what's going to happen. Job completed. Oh, 100% accuracy. Nice. No, that's not what I wanted. I just wanted to got the... Oh, no, maybe it is. If I go show classification... Cool. Classification got bit. Of course, we've got the little circle there to show us it's right. Okay, so it's doing it. It's doing it. That's pretty cool. So we've got a model that works. If I actually look at deploying this model... Ooh, we're not on the phone. Ooh, okay, so we can test it out on the phone. That's nice. That is very nice. So let's just grab my camera thing on my phone. Go here. Now on my phone. Exporting models. So it's actually currently creating a model as a WebAssembly to run on my phone. It's fine. Okay, so that's doing its thing. What's doing its thing? Let's have a look. This is still installing all its bits and pieces. So lots happening. But just looking here. Okay, so there's firmware for this board, this HiMax WI Plus. So that's your firmware I can install that will just work with it. That's nice. So now I can download a TensorRT library. So I have to work out the jets and stuff works. Arduino, C++. So maybe if I look at the Raspberry Pi thing, oh, nice. So there is a Linux runner. I just run this on the board, on the device, and that will run it on the camera, and then give me a nice little preview window. Ooh, that could be exciting. So I think that's going to be how I'm going to do it. Give access to my camera. Okay, so if I do this over here, click classify. Oh yeah. Don't know if you can see that, but it's detected bit and put a circle in bit. If I do 2 bits, because you know I am a 2-bit programmer. It's only got 1 bit. Oh, there we go. Do it from a different angle. We get 2 bits. That's pretty cool. But you know what? Let's make this a bit easy to see. With the power of long cables, I'll just plug this little puppy in here. Launch QuickTime Player. Yeah, go away. File, new, movie recording. There we go. You can actually see it on my phone. So if I do the next photo, and I just go classify there, we get bit, next photo. So great at doing more than one. Nothing detected. Oh, there we go. That got 2. So it's probably just the quality of my training data. Usually, when things are not so great, it's the quality of the training data. So if I go a long way out, I can't do it. So it's kind of because I trained it on bits up close. There you go. There's 2 bits there. Okay. So again, it's probably just my training data. It's usually what happens with these things. It's the training data. But that's pretty cool. That is pretty cool. So I did all that using my phone, and this still should be this FOMO model that's tiny. And so to run a Raspberry Pi, there's a Linux SDK to implement your model with favorite programming language. So there's an EIM file I can download and use the Linux SDK that's available in Python. Okay, nice. So I can use the Python SDK with the camera and just run it through that model. So what format do I need then? I need So Linux SDK. There's the SDK. Right, so if I go here, I go to my dashboard, and then where are we? Go to dashboard, enable show Linux deploy options. Show Linux deploy options. So that means if I now go to deploy, did I not save that? Dashboard. Cool. Okay, so what we've got is come out firmware. So binary for Mac OS, but not an Apple Silicon, so not one that takes advantage of the M1. But we've got Linux, ARM v7, Raspberry Pi 4, Jetson Nano. Nice. So I wonder if I go back to the Linux model thing, go to NVIDIA Jetson Nano, set it up. Because I think the Jetson Nano, if I'll have a look, I think it's got the same camera connector as the... Yeah, it's got the same camera connector as the Raspberry Pi, so I can literally plug in my Raspberry Pi camera into Jetson Nano and run this on a Jetson Nano. Okay. Let's go here. This is the Linux one we want, so let's go for the small one. Just do some analysis on it before we do it. Okay, cool. So that's installed that Edge Impulse stuff. Kind of doing two things at once here, but let's see whether I can now capture data with Edge Impulse. So what do I have to do to? Let's go back to the Raspberry Pi thing. Edge Impulse Linux. So let's just put that in there. Edge Impulse Linux. Go over here. Got to hide my got to get all my login details. Let's just copy that. And then Microsoft.com. Put a password. FOMO. I should have done the -- disable microphone. Right, cool. Okay, so yes, so it is, you can't use Raspberry Pi Lite with all this. But in theory though, if I go to... So build that, it downloaded, isn't it? So if I go back to here, go to devices. Here's my Pi connected. That is connected, and now I go to data acquisition. And there's my camera feed. So if I actually turn my camera around, cool, there we go. So I turn my camera around, I can point at the bits, the various bits, and start sampling. Nice, nice. So once I've got the camera, it's a live feed here. I can literally, if I take my palm my camera, point it at the bit. It's very small. Let's move my... Need to kind of get this fixed onto something, but yeah, in theory, a bit straight. Need to improve the lighting, but I could do that, and that gives me a bit there. Ah, nice, nice. Did it with my phone, so I'm not sure how well it's going to actually work on the Pi then, because the data coming in is different from the data on the data used to capture it. But that's pretty cool. So now in theory, I've downloaded my model. What I should actually be able to do then is just drop out of that. Did say to test it on Linux, there's this Linux runner. So what I could do is I just go, if I do the Linux runner, let's actually run it. That's running the Linux runner. Download the model. Do its thing. And it says if I just go to localhost that should spit out, when it's done its thing, it should spit out a link that I can use to bring up to have a browser. So that way I can see it. Okay, so let's just copy that URL. What if I open the URL? Open URL. Doesn't want to do it. Oh, it just took a bit of time. I'm not sure how well it's going to work. Let's get the bits out of the way, because the lighting is not the best from this. It's not the best camera. Oh! Nice! It's doing it! It's doing it! It's doing it! Now, are we really getting 60 frames per second? Time for... Okay, that's... I mean, it's orbiting. It doesn't seem to be any higher than 20 milliseconds per inference. Well, that one's 25 milliseconds the inference. So 25 milliseconds the inference. If I go, let's do a bit of calculation here. So 1,000 divided by 25, it's 40 frames a second. So it's the slowest speed is 40 frames a second. But with sometimes the inference is up to, I'm seeing numbers there, 7, 8, 9. Oh, wrong way up. Let's get the camera the right way up. Yeah, seeing numbers like 7, 8, 9 milliseconds, so that's 100 times a second. Yeah, it's recognizing bit. That's pretty impressive. Seeing as I trained it with data captured from my phone, and let's be honest, the cameras in iPhones is substantially better than the Raspberry Pi camera module V. There's even a V2. It's a V2.1. So, it's using a much different data set. That's really cool. That is really, really cool. That works so well. It does get that speed. Nice. Nice. So I wonder then what it would get. On a Jetson Nano. So it's saying, okay, due to some incompatibilities, we don't run models on the GPU by default. So just think about how we can take this on a Jetson Nano next. It doesn't run on the GPU by default, but I have to follow the TensorRT instructions of the C++ SDK. So the way to get it working... Okay, so we have to do stuff. Right, so I don't. So by the looks of it, I can't just use the same tool. If I run this on the Jetson Nano, I won't get GPU power unless I have to build it and then write my own application to do that. I wonder if there's a sample app. Ah. But yeah, I'm really impressed so far with how this has come out. I'm really impressed. So it works. It works. It works well and gets just, yeah. Let's try with a bit in a different environment. Let's put a bit over there. See when there are too many cables. Yeah. Bit in a different environment. Let's try a bit over here, for example. Ah! Dropping raccoons everywhere. So if I hold a bit at the back and then point that. Oh, this is magic. This is absolute magic, literally. And I mean that in the Arthur C. Clarke, any sufficiently advanced technology is indistinguishable from magic thing. That's brilliant. That's absolutely brilliant. Yeah, it gets the speed that I would expect. Cool. I think that was a very successful day's work. Okay, I'm going to wrap up there, and what I might do, I'll do the same thing again next week. But next week I'll try it on a couple of other devices. I'll go big and go small. So I'll try it on a Jetson Nano and on maybe an ESP32 cam as well. See how we kind of get on with bigger and smaller devices. But yeah, let's wrap it up there. Thank you everyone for watching this stream, and I'll see you all this time next week. Goodbye all. Thank you.